Welcome back to CS111. In this lecture, we're going to take a look at a variant of the queue known as a priority queue, and we'll see how to go and create a linked implementation of one. We're also going to look at how we can make our objects be comparable between different objects of the same type so that we can sort them for use with a priority queue. Let's start off by taking a look at what priority queues are. So in a traditional queue, things operate in a first in, first out manner. The first thing that we go and enqueue is going to be the first thing that we dequeue. Priority queues work differently. Regardless of the order that we go and add something to the priority queue, things are going to be dequeued based on their priority. And as we go and create our priority queue, we can determine what we want to make be the highest priority. So that's part of the design of our implementation. In a priority queue, if we have multiple items that have that same priority, there normally isn't any particular guarantee as to which one will be returned first, although there's actually ways in our implementation that we can go and use the order that things were inserted as part of determining the priority, or to serve as a tiebreaker. The way that we go and determine the priority of the items that we're adding to our priority queue is by going and calling the compare_to method on those objects. The compare_to method is not something that's there automatically on the object. It's something that we have to make sure the objects that we're storing have. And we can do that by going and implementing the comparable interface, which has a generic parameter of type T, where T is the actual type of the object itself. So any of the standard wrapper types that are provided in Java, so like integer and double, as well as string, those all go and implement the comparable interface already. We can also go and create a compare_to method that goes and serves to implement that interface on our own custom classes. And that's something that we're going to do later in this lecture. One of the things to know about working with priority queues is that we're not able to go and store null values, because if we have a null object, we can't go and call compare_to on it. So we're going to actually have to have real values for the things that we store inside of our priority queue. Let's go ahead and work out what we want to have our priority queue interface support. With our interface, as we've been doing with our other data structures, we'll want to add a generic parameter T so that we can specify a particular type of data inside of our priority queue. And we're actually going to go and place a restriction on T to ensure that T is going to be a type that implements the comparable interface. The set of operations that our priority queue needs to support is going to be pretty similar to the regular queue. We're going to have a way to go and create the priority queue in the first place, and we'll do that using the constructor for our priority queue class. And we'll need ways to go and add and remove items from our priority queue. I'm naming them as add and remove for these methods as opposed to enqueue and dequeue like I did with a regular queue, to drive home the fact that this priority queue in fact does not act quite the same as a regular queue. When we go and remove an item from the priority queue, we're not necessarily removing the item that was first in the queue. Instead, we're going and actually removing the highest priority item. It's going to be up to our particular implementation of the priority queue how things get stored internally. As long as the priority queue we go and code has a way to go and add something to the priority queue, and its remove method goes and removes and returns the highest priority item, we could store things however we wanted inside. Now, in the actual implementation we're going to be coding up, we're going to store them in sorted order, but strictly speaking, it doesn't have to be that way. As long as it meets the definition of the interface, that's what really matters. We need to have a non-null item stored in order to be able to go and call the compare to method on it. So our add method will go and throw a null pointer exception if somebody tries to add an item that's null. If we try to go and remove something from an empty priority queue, we'll throw a no such element exception. We're also going to have a peek method that will retrieve the highest priority item but not go and remove it from the queue. It's not going to change the contents of the priority queue. This method is also going to throw a no such element exception. We're also going to have methods to see if there's anything in the priority queue. That'll be our isEmpty method that'll return a Boolean value. We'll be able to find out the exact number of items that are stored using the size method that returns an int. And we'll have a toArray method that will go and return an array of objects containing the items that are in our priority queue. One thing that we're going to add here with our priority queue implementation compared to what we did with our regular queue is we're going to have a toString method. And I'm adding this here just for convenience sake. ToString will go and return a string that has a listing of the items that are stored inside of the priority queue in order. The base object class that everything in Java goes and inherits from already has a toString method. The default that we get when we go and write a custom class is what we go and inherit from this object class. It's going to be the package and type name and then the address in memory where our current instance goes and lives. Knowing where in memory our priority queue lives really isn't all that helpful. It's a lot more useful if we can just go and pass the object that represents our priority queue directly to like system.out.print. So with our toString method, we're going to be able to go and do that. This method will return a string. Here in Eclipse, I've already imported the starter code for this lecture. I'm going to create a new project that'll be priority queue interface. And I want to make sure that I don't have the create module-info box checked. Inside my new project, I'm going to go and add a package. In sticking with the conventions we've been using, I'm going to call it edu.wvu.cs111.priorityQueueADT. And I'm going to go ahead and make an interface inside of that package. So I'll right click, go to new interface, and I'm going to call this priority queue interface. And I'll click finish. I want to go and add a generic parameter to my priority queue interface so that I can specify what type of data I'm going to be storing in my priority queue. I'm going to start off with the tGeneric value like we've been using all along, but I actually want to place some restrictions on t. I want to make sure that t goes and implements the comparable interface so that I have the compare to method so that I know that I can actually sort things, so that I can actually rank them in their priority order. I'm going to go and place a bound on t to say that it needs to go and implement the comparable interface. When I'm placing bounds, I don't have the implement keyword available to me, but I do have extends. So I want to say here that t extends comparable. But this isn't quite right either. I've got a warning here that comparable is a raw type, and that since it's a generic type with this t parameter, references should be parameterized, which means I need to specify the type that I want for the comparable. The way comparable works, it's expecting the type parameter that's passed to be the type of the objects that we might be comparing. So if I am going and implementing comparable inside of the t type, the objects I'm going to be comparing are normally going to be of t type as well. Where things get really messy is that I can actually go and use some other types other than just t here. Specifically, I can use anything that's a superclass of T, basically anything that T goes and inherits from. I can't use anything that inherits from T, though. I can just use stuff that's upstream of T. To go and specify that, what I'm going to do is inside the set of angle brackets for comparable, I'm going to do question mark super T. So anything that is a superclass of T is going to be okay to use with the comparable interface, and I need to make sure that T goes and implements or extends, so inherits, from the comparable interface. Since it's an interface, we're going to go and implement it. It looks a little weird, but this is what you actually want to end up with here. This is going to make sure that we actually have things that we can validly do a compare to call on with two different objects to see how they relate to one another. Go ahead and drop in some JavaDoc for my interface. So this is an interface for representing priority queues. I'll list my author name. And for the T type, I'm just going to say that this is type of data to store that implements the comparable T interface. We'll just note that's actually super T there. Inside of the curly brackets for the interface, I'm just going to list the different methods that I have. I've got a void method to go and add items, and it'll take a parameter of type T to go and store in our priority queue. We'll have a Boolean return type for isEmpty. We'll have a T return type for peak that'll go and tell us what the highest priority item is. We'll also have a T return type for a remove method to go and remove and return the highest priority item. Our size method is going to return an int. We'll have a method that's going to return an object array called toArray. And then I'm also going to go and list my toString method. So it's going to have a return type of string. Now, any class that I say goes and implements priority queue interface will automatically qualify as having a toString with it, even if I don't explicitly go and provide one, because anything that goes and inherits from object has a toString. There's no way for me to specifically force that the class is going to have to override toString. Since there's already a toString there, technically it's going to meet the requirements for implementing the interface. But I'm going to still go ahead and list this method here just as more or less a reminder that I do want to go and override toString. And then I can also provide some JavaDoc on it. So let's go ahead and do our JavaDoc. Here I finished up the JavaDoc for my methods. I went and noted all the exceptions that we might throw with null pointer exception and no such element exception. And I've also gone and clarified that for my toArray method, index 0 is going to be the highest priority item, and that with toString, we're going to list the highest priority item first. Notice that you can actually go and wrap JavaDoc for your description here of a method, so that if you have something that's really long text, you can just go and put a star on the next line and complete your comment, rather than having your comment run really long and then require scrolling in order to be able to see the full thing. Now that we've designed an interface for our priority queue, let's take a look at how we can actually go about implementing it. As we discussed, with our priority queue interface, it's not dictating anything internally about how our data is stored. It just says that we need to have a way to be able to go and add things to the priority queue, and that when we go and remove things, we're going to be removing the highest priority item. What goes on inside with how we store things is up to us. Most of the time, though, with priority queues, you're going to go and store the values in sorted order. So at the time you go and add a new thing, you're going to go ahead and figure out its correct placement relative to the other items so that your data is sorted. Something that you'll find as you work with different data structures is that they have different performance characteristics depending on the type of operation that you're trying to go and perform. For example, when we're working with a priority queue where we're going and sorting our data at the time we add it, that takes a little bit of time when we're working with a linked nodes, with a chain, or with an array. It goes and takes big O of n time when we go and add items. And that's because we potentially have to go and iterate over n items that might be stored to find the correct spot. Once we have things stored, though, we can remove them really quickly. That's a constant time operation, big O of 1. And that's the fastest time that you have available. You can't beat big O of 1. One fairly common way to store data for a priority queue is in what's known as a heap. And I've got a diagram of one here on the screen. A heap is a way of storing information in a sorted manner. With heaps, it takes log of n time to go and add things to our priority queue. So it's a little bit faster than the just n time that we saw with a linked node or with an array. But there's a trade-off when we go to remove stuff, where we can go and remove in constant time with a linked node or with an array. It still takes log of n time with the heap. So some operations are faster, some are slower. And especially as you start to work with data structures like lists, where you will be seen here where we're often maintaining the data for a longer period of time, it might be that you tend to go and do more of one type of operation. Maybe you go and try to search for particular items a lot more than you go and add new items. Going through and looking at the performance characteristics of the different operations there might lead you to choose a style for your implementation that's one way as opposed to another, because you know that it's going to lead to a little bit better overall performance with the particular mix of tasks that you're going to be performing. We're going to focus on an implementation that uses chains of linked nodes. And we're going to work with singly linked nodes using the singly linked node class that's part of the starter code for this lecture. When we go and add new values to our priority queue, we're going to create a node and we're going to insert it into the chain in its properly sorted location right from the get-go. That way, when we go to remove items from the priority queue, we have that constant time operation. We know we just have to go and grab the front node from the chain. We're going to need to have two fields in our implementation. One to keep track of the size of how many things we have in our priority queue, and another to the front node of the priority queue. Since I have to go and iterate over all the nodes to find the correct location to go and insert for the sorting, there's no benefit here to having a rear node, so I just got rid of that. Let's go ahead into Eclipse and see how we can code this up. Here in Eclipse, I created a new project for my linked priority queue, and I adjusted the Java build path to go ahead and add the nodes and priority queue interface projects to the build path so that we can use their code. Let's go into the source folder here, and I'm going to right click and go to new package. And I'm going to create a new package that I'll call edu.wvu.cs111.linked_priority_queue. And inside that package, we'll go ahead and make our linked priority queue class. So I'm going to right click and go to new class, and I'm going to call this linked priority queue. I'm going to click the add button beside the interfaces, and I'm going to search for priority queue interface, and we'll have Eclipse go and set up our new class so that it implements this interface. So I'm going to click finish. You can see I've got my new file here. I need to go and add the generic parameter to the linked priority queue class. So I've got T here, but if you notice, I've got an issue here with the T parameter. It's saying the type T is not a valid substitute for the bounded parameter that I set up in my interface, where T extends comparable, which has its own generic of $super T. Basically, since I went and placed a restriction on the types that are allowed for T in the interface, and I'm saying that I'm going and implementing the interface, I've got to place corresponding restrictions here on T for the class itself. So I'm going to type in the same thing that I did back in the interface. I'm going to say that T extends comparable, and then since comparable has its own generic, I'm going to do super T. So T is going to have to type that implements the comparable interface, and for the comparable interface is going to take a generic parameter where it's going to have to be either T or a superclass of T. So something like object that T goes and inherits from. That goes and takes care of that error that we had with the T here. Let's go and fix this other error that's marked with linked priority queue by using the quick fix to have Eclipse add unimplemented methods. Now, notice as we look through this list of methods here that toString does not appear, even though we have it listed in the interface. And the reason why is because linked priority queue, as something that goes and inherits from the base object class, already has the toString method, the one that it's inheriting from the base object class. So from Java's perspective, from Eclipse's perspective, toString was already satisfied by that. We don't have to specifically override it here, although in reality we do want to go and override it here so that we get the output format that we're expecting. Before we do anything more, let's go and add some Javadoc. I'm clarifying that with that T generic is the type of data to store, and then we want to make sure that we say that it implements the comparable super T interface. Somebody should be able to go and see that by going and looking at the definition here, but that just makes it a little bit more obvious. Let's go ahead and add the fields for our class here, and we said that there were going to be two. We'll have a protected field that's going to be of type singly linked node with that T generic that's going to point at our front node. And then we're going to have a protected int to keep track of how many items we have stored. And we're calling that size, sticking with our naming convention here. I need to go and import the singly linked node class, so I'll use the quick fix for that. And I'm going to provide some Javadoc. As we discussed, we're not going to provide a rear node field here just because I have to start the front anyhow when I'm going and adding new things so I can find the correct location to go and insert so that we're sorted. So there's no reason to keep that rear node field. It would just basically be more work without any real payoff. Let's take a look at what we need to do when we go and call the constructor to make a new linked priority queue. There's basically going to be two steps here. We're going to have to go and set the field that we just made for our front node to null to represent that it's an empty priority queue. And then we'll go and set our size field to 0 to also indicate that we have an empty priority queue. Again, these are the default values for those fields, so we could skip the constructor, but let's go ahead and make one anyhow. For our constructor here, it's going to have a public access modifier, and we're going to call it linked priority queue since that's the name of our class. We don't need to go and provide any parameters because none really makes sense in our context here. The first thing that we'll do is we'll go and set the front node to null to reflect that we have an empty priority queue. So I'm going to say this dot front node is equal to null, and then I'm going to go and set the size to 0 since that's also should be showing empty. So we'll do this dot size equals 0. And I'll provide a little bit of Javadoc here. So this is a constructor for a new priority queue of linked nodes. The process for going and adding new nodes to our linked chain for the priority queue is a little bit complicated. It depends really on which of 4 different scenarios we fall into. Things are most straightforward if the priority queue is empty, because we're going to have only one node when we're done. If we have a case where the priority queue is not empty, we're going to have to start looking at where our new node should fall in relation to the existing nodes. It could be that it's going to need to go someplace before the existing front node, someplace after the existing front node, but before other nodes, or someplace after all of the existing nodes. As it turns out, things are actually going to kind of break down into two groupings here when we go to code stuff, but let's walk through these different scenarios. Our simplest case is going to be when there is nothing in the priority queue yet. Here, to go and add something, we'll create a new node, and then we're going to point the front node field at that new node, and finally, we'll go and increment size. Let's take a look now at the other case where our new node is going to end up being at the front of our queue. This is where it has a higher priority than the existing front node. In this example that I'm showing here on screen, we're going and storing integers. And we're taking the default behavior of compared to for an integer, which basically is that a lower number we're going to interpret as being higher priority. So if we're going to go and create a new node here with the value of 36, what's going to happen is we're going to go and compare that new node to the existing front node. We're going to find it should go first. At that point, we're going to go and set the new node's next node to be the existing front. That way, once we go and make our new node be the front, we'll still be able to get to the rest of the chain. Once we've gone and set that, we're going to go and update the front node field to go and point at our new node. And then we have to go and increment size. So again, we're still fairly straightforward with what we need to do here. In our implementation, we're also going to place our new node in front of the existing front node if they have the same priority. Our next two cases are going to involve looping over at least portions of our chain of nodes. First here, we're going to look at where the new node we're inserting has a lower priority than the existing front node. So basically, the new node is going to go someplace between the existing front and, for this example, we're going to say the existing rear. We're going to start off by going and creating our new node, which in this example we're giving the value 60. So looking at the existing values that we have, we can see on our own that the new node is going to become the third item in our chain. What we're going to do after we go and initially compare the new node to the front node is we're going to see that, okay, it's got a lower priority than the front node, so we'll set up our loop to iterate over things. We'll create a current node variable to point initially at the front node, and then we're going to keep on looping until we get to the point where either the new node is going to be between our current node and the node that is right now after the current node, or we basically have no more nodes to go and take a look at. So here in this example, we've got where our current node is 55, the node afterward is 75, and since we're trying to add 60, I know it's going to go in between those two. Once I've gone and ascertained that I have current node as the node that'll be right before my new node, I'm going to go ahead and set my new node's next node to be the existing node after current node. So I'm hooking up 60 to 75. And then I'm going to go and set my current node's next node to be that new node. So I'm just continuing the chain on through. And then to wrap things up, I need to go and increment the size field. Our last scenario will be where we're inserting a new node who's going to have a lower priority than all of the existing nodes. In this implementation, we are going to have to go and look at every single node to determine this. You could go and design an implementation that did have a rear node field to jump and compare directly against the existing rear node, but honestly I don't really think there's a whole lot of value for that in most cases, so I just designed this implementation that we just loop on through. It's sort of a trade-off. You might see a little bit of a performance gain there, but there's also more complexity in managing things, so I'm just gambling that it's not worth it for the data I'm working with and the number of elements I'm dealing with. Here, I'm going to go and create a new node with a value of 75, and since 75 is higher than all the existing values, eyeballing things right now, I know that it's going to end up coming after all of the existing nodes in our chain. I can't figure that out programmatically though until I actually go and loop over all the nodes to go and figure out that in fact the new node is going to have a lower priority or a higher number with an integer here than the very last node. So I've got current node set to the existing last node in the chain. What I'm going to do then is go through and set current node's next node to be my new node, which is going to tack it on to the end of the chain. And then I'll go ahead and increment the size field. Let's go into Eclipse and we'll see how we can code things up for adding new elements. Before I go and code up the add method, I'm going to do isEmpty first because I'll use the return value from isEmpty in my code for add. Here, I'm just going to take a look at the size and figure out if it's 0. I could also go and check to see if front node was null, but I'm just going to go and use size for this check. So I'm going to return the value I get from evaluating the expression, this.size equal to 0. My add method is going to be much more complex. The first thing that I'm going to do is check to see if we have a null value that we're trying to add, which is something that we are not able to do because it's going to cause problems when we try to use the compare_to method. So the first thing that we're going to do is figure out if it is a null that we're trying to add, and if that's the case, we're going to throw a null pointer exception. So I'm going to see here if item is equal to null, and if so, I'm going to throw a new null pointer exception with the message that a null value cannot be added to the priority queue. So if we get past there, we can presume that we actually have some sort of real value that we want to store. We're going to go ahead and create a node to store that new value. So I'm going to make this var new node, and I'm going to call the constructor for my singly linked node class with the tgeneric parameter. And I'm just going to provide one argument here with the value that I'm trying to store. I mentioned when we were going through the diagrams of how adding things was going to work that the stuff would kind of fall into two categories. That's going to be what we'll figure out here with this if statement we're going to write. So essentially what we're going to do is check two conditions to see if the new item should become our front node. I'm going to have an if statement, and the first condition I'm going to check to see if my priority queue is empty, because if there's nothing else already, then the new node will become the front because it's the only thing there. The other condition that this is going to occur in, and I've got a logical R with 2 bars for that, is if the new node has a higher priority than the existing current node. So we said lower numbers or higher priority with integers, but we're basically just going to take a look at whatever result we get back from compare_to. So compare_to as a method is going to go and return either a negative number, 0, or a positive number to go and show the relationship between the two values. For the value that I go and call compare_to on, it's going to return a negative number if that value should come first. It'll return 0 if the value that I'm calling the method on is the same as the argument that I go and pass to the compare_to method. And it'll go and return a positive value if the argument value should come first before the value in the object that I'm calling compare_to on. For my check here, what I'm going to do is I'm going to go to front node, I'm going to get its data, and then I'm going to call compare_to on that. and I'm going to compare it to the item that I'm trying to add. And I'm going to see if it is greater than or equal to 0. And if it is, that means that the value that's in my front node should come at the same place or after the new node that I'm adding. And I'm basically saying if it's going to be in the same place in terms of value for things here, I'm going to go ahead and make the new node go first. And that's basically just to simplify my implementation a little bit. So if I get inside of this if statement here for it being true, that basically means that my new node should be the front node. And sometimes when I'm going and writing if-else code here, I'll go and just drop a single comment right inside the if block or the else block to basically indicate this is what this block of code means happened. So here I'm saying we're in this block where this new node should be the front node. That way it's really clear to me as I'm looking at things exactly what is going on if my execution actually falls into this block here. So the new node is going to be the front node. So in order to do that, I'm going to set the next node for my new node to be whatever the current front is. So new node dot set next node is going to be this dot front node. This is going to work whether or not there's anything in the priority queue already. If there is, that existing front node is going to become the thing after my new node. If there isn't anything in the priority queue right now, front node will be null, and that just means that there's not going to be anything, at least for the moment, in the chain after my new node. Once I've gone and set the next node, I want to go ahead and set my front node. I'm going to make that be my new node. So we'll say this dot front node equals new node. Next, I'm going to create an else clause that'll handle both of the cases where the new node should come somewhere after the front node. Here, we're going to have to go and iterate over the chain to figure out exactly where this new node needs to go. So I'll create a var that I'm going to call current node, and I'll set it to the front node, and then I'm going to have a while loop to go and iterate over my chain. Inside the condition for my while loop, I'm going to keep on advancing current node down the chain while two things are both true. And that's while there is another node after the current one, and while the node after the current one should come before my new node. The reason why I'm looking at the node after the current one, in part, is because I'm dealing with singly linked nodes. I don't have the ability to go backwards, so I need to make sure that I'm basically looking one spot ahead, because I'm always going to have to go and do my add after the current node, because that's the only ability I have. I can only go through and set next node. I don't have the ability to come backwards if I overshoot things. So I'm going to have my while loop here first of all go and check to ensure that there is another node after the current one. And when I went and designed the singly linked node class, I built in a helper method called isLastNode that returned a Boolean value of whether or not that node was the last one in the chain. I'm going to make use of that here. So I'm going to go through and say that we will continue to loop while not, with that exclamation point, current node dot isLastNode. And then I'm going to do a logical and. So I'll have two ampersands. And here I'm going to go and check the position of next node relative to the item that I'm trying to go and add. So I'm going to say current node dot get next node, and then I'm going to get the data for that next node, and I'm going to go and compare that data to the item that I am trying to insert. And if the value is less than 0, which means that next node will come before the item that I'm trying to insert, I'm going to go ahead and just move on down to the next node. And then we'll go and repeat that check. So we'll say current node equals current node dot get next node. We'll fall out of this loop when current node is the node that's going to be immediately before where this new node is going to go. Either because current node is the last node and there's nothing else for us to go and iterate over, or because the node that is after current node is going to be after new node if we go and look at their values. So basically we're going to go and insert right after current node. So once we get out of this while loop here, we'll go ahead and add our new node after the current one. And for that, we're going to go and for our new node, set its next node to be current node's existing get next node. That way we don't lose the rest of our chain. Once we've gone and set the new node to go and point at the one that's after current right now, we're going to go and say that current node's next node is going to become our new node. So I'm doing current node dot set next node, and that's going to be new node. And then I'll get out of my else block. Either way, no matter which of the four options we basically had to go and insert things, we do need to update the number of stored items. So we'll do this dot size plus plus, and that'll increment it for us. While our method for going and adding things to the priority queue was a lot different than what we had with our regular queue, peek and remove are going to be essentially the same as with a regular queue, because we're just going to go and take the item that's at the front. That's going to be our highest priority item. Let's go ahead and do the peek method first. In here, I want to make sure that there actually is stuff inside of our priority queue. So we'll start off here with our check for an empty queue. So I'll do if this dot is empty, then I'm going to throw a new no such element exception with the message that the priority queue is empty. And I'm going to use the quick fix here in Eclipse to go and import the no such element exception class. Once I've made sure that there actually is something in my priority queue, I just want to go and return the data from the front node. So I'm going to return this .front node .get data. When we go to remove things from our priority queue, the operation is going to have a slightly different result depending on how many things are already there in the priority queue. Let's take a look first at an example where there are 4 things in our priority queue. So even if we go and remove the first one, there's still going to be 3 things left. Here, we want to go and create a variable to store the value that we're going to be removing from the priority queue. So 36, which is our current front node, is what we're going to store. Once we do that, we want to go and update the front node field so it goes and points at the node that comes after the existing front node. We're basically cutting that front node out of our chain. Once I've done that, I can go ahead and decrement the size field, and then I can return the value from the removed node. If we have a case where there's only one item in our priority queue to begin with, we're going to end up with an empty queue once we go and remove it. Here, we'll still go and store the value that we're removing in a variable. When we go and update the front node, it's going to end up being set to null. This is actually still going to be the same code as with our other case, because we're still going to be going through and setting it to whatever comes next after front node. It's just in this case that what comes next is null. What that basically has the effect of making our front node not be pointing at anything so that we have an empty priority queue. Once we do that, we're going to decrement our size field, which will become 0 since our priority queue is now empty, and then we'll return the value from our removed node. Here in the remove method, I'm going to start off by going and calling peek. And this will get us the value that's currently stored in the front node if there is in fact a front node, and if not, we'll allow peek to go and throw our no such element exception. I'm going to store the return value from this.peak inside of a variable called front data. Once I've got that data value securely stored there, I can go ahead and update my front node field. So I'm going to say this.frontNode equals this.frontNode.getNextNode. If we have anything else that's in our chain other than the node that we're going to be removing, the second node would become the new front node. If there was only one thing in our priority queue to begin with, getNextNode will be null, so we're going to be setting front node to null. This line of code will handle basically both of the cases that we looked at when we diagrammed out the operations. Once we go ahead and update our front node, we want to decrement the size to reflect that we have one fewer thing stored. So we'll do this.size minus minus, and then we're going to return front data. Our size method is basically just a getter. We'll go ahead and return this.size. With our linked implementation here of the priority queue, if we want to do something that'll involve looking at each of the nodes that we have stored, we're going to have to iterate over them. So we'll create a current node variable, and we're going to point it at our front node. And then we're just going to go and keep on looping until we get to the point where current node gets set to null. And that's going to happen right after we go and finish up with the last node in the chain. So right now, current node is pointing at the last node in the chain. Its next value is null because there's nothing else in the chain. If we go and set current node equals current node dot get next node, current node is going to end up being set to null. And at that point, we'll go ahead and fall out of our loop, and normally we would go and return whatever result we had computed, or we would just go and leave our method. Our toArray method is going to follow that basic process to iterate over each node to store its value inside of an array. We'll start off by going and creating our new array to store the values that are from our priority queue. I'm going to create this var destination array, and I'm going to set equal to a new object type array, and I'll size it to store just the number of items that we have in our priority queue. So this.size. Once I've got that array made, I want to go ahead and iterate over the linked chain of nodes to go and populate the array. So I'll create current node as var current node equals this.front node, and then I'm going to loop while current node is not null. I should not have any problems here with overrunning my destination array's final index, since I'm presumably going through and keeping track of my size correctly. I could go through and have another check here to make sure that the index that I was going and looking at was a valid one, but I'm going to dispense with that. One thing that I do need to do, though, since I'm going and storing things in array, is I need to keep track of what array index I'm going to be writing the values to. So I'm going to create this int that I'll call IDX. I'm going to set it to 0 here, and that'll keep track of my position in the array. Inside the while loop, I'm going to store the value of my current node in the destination array. And I'm going to say destination array sub IDX is equal to current node dot get data. Once I've got that data stored, I'm going to go ahead and increment my counter so that I go and look at the next element in my array next time through. So we'll do IDX plus plus. And then I want to go and move to the next node. So we'll say current node equals current node dot get next node. When we fall out of the loop, we'll have a populated array, and we can just return that destination array. The last method that we're going to do will be an override for the toString method that we inherited from the object class. This will allow us to provide a nicely formatted output showing the contents of our priority queue. I'm going to have to code this all from scratch here. I don't have a stub to start from, and that's because Eclipse saw that even though I have toString defined in my priority queue interface, linked priority queue, just by virtue of being something that goes and inherits from object, already had a toString method implemented. So it did not add a stub because it wasn't an unimplemented method. In this case, though, I want to go and override what's there, so I'm going to go and code things up here myself. I'm using the @override annotation to note specifically that this is intended to go and override something that's been inherited, the version from the object class in this case. It's going to be a public method. It'll return a string, and it's going to be called toString without any input parameters. What I'm going to do inside of my method here is I'm going to call toArray to go and get the data that is currently stored inside of my priority queue. And this is going to go through and simplify me generating my string. I can actually take advantage of the fact that I'll have things as an array to save me some coding here. So I'm going to say var data array equals this dot toArray. Once I have the data from my priority queue as an array, I can go and take that and feed it into the toString static method of java.util.arrays. That's going to go and return a nicely formatted string. It'll have a set of square brackets, and then it'll have the values inside separated by commas. And I'm just going to return that output directly. So we're going to get something that'll look like that. So I'm going to return java.util.arrays.toString, and then I just need to go and pass it my data array, and it'll take care of going and formatting everything and generating a string that'll look like this, and then we can just return that string directly. So now if we go and print an instance of our priority queue, we'll actually have a nicely formatted output telling us what is stored inside of that priority queue. Now that we've seen how we can create a linked priority queue that works with objects that implement the comparable interface, let's go and see how we can actually create our own classes that will go and implement the comparable interface. So what comparable does is it goes and gives us a way to determine how things should be ordered, like if we're trying to go and sort data. And the comparable interface basically is a standardized way to go and do it. There's something similar in C# if you're coming from that language too. And basically it says that it's going to have this compare to method that's going to go and take the object that we're trying to compare against, and it has a well-defined set of return values that we can use to go and order our objects. Now, the common built-in classes in Java, things like strings, the wrapper types with integer and double, those things, those already go and implement the comparable interface. But classes that we go and create ourselves by default do not. What we want to do is go and actually implement that in our own classes. To go and implement the comparable interface on our own classes, we're going to have to provide a compare to method that returns a primitive int. And the return values from compare to have been defined to indicate how the object that we're calling the compare to method on and the object that we're passing as an argument when calling compare to should be sorted relative to one another. If compare to returns a negative number, that means that the item that we're going and passing as an argument should come after the object that we're calling compare to on when we go and sort things. So for example, if my current object is the number 5 and I go and pass an argument that's the number 7, compare to is going to return a negative value because 5 is less than 7. 5 should come first when we're going and sorting. Compare to will go and return 0 if the two objects are equal. So like if I had an object that was storing 5 and I called compare to on it and I passed 5 as an argument, I would get 0 back. Compare to will return a positive number if the object that we're going and passing as an argument should come before the object that we're calling compare to on. So that would be like if we're storing 5 in our current object and I'm going and passing 3 in as an argument. 3 would come before 5, so that argument that we're going and passing would come first when we're going and sorting. A lot of times what you're going to end up doing here when you're writing your own custom classes is that you're going to go and just make use of a compare to method that's provided on a field that you have inside your class. So for example, with this my class that I have on the screen, I have this integer field called data, and the integer wrapper class has compare to implemented already. So what I'm just making sure to go and do in compare to is that the object that we're going to compare to is not null, because I can't really compare against a null value accurately. Assuming that it's not null, I'm just going and using the compare to method in the integer class to actually go and compare things. I'm not bothering to write any code of my own. Although I can certainly go and write my own code to determine what the result should be. And that can be helpful if I need to go and fine tune things, or maybe if I need to have complex logic that would go and determine the ordering. It just depends on what exactly you're trying to do, what data you're representing in your class, how you might go and handle things. Priority queues are great for being able to sort data. And by going and implementing the comparable interface in our own custom classes, we can use those priority queues to go and sort our own data based on some criteria that we've determined. To see how things are going to work, if we try to do this, we're going to create a new class that we're going to call patient. And it's going to be used to represent patients who are waiting for medical care in an emergency room, so we can determine what patient should go and get seen first. Let's go ahead into Eclipse, and we're going to go and code this up. Here in Eclipse, I created this new comparable objects project, and I went ahead and made a patient class inside of it. I'm going to go and indicate that my patient class implements the comparable interface. So I'm going to say that it implements comparable, but comparable takes a generic parameter of its own. And what you're normally going to use for this generic parameter is this same class itself, because that's going to go and set that the compare to object is going to be of the type patient. I'm going to go ahead and have Eclipse add our unimplemented methods, which turns out to just be one, the compare to method. Before I go and code up the compare to method itself, I'm going to finish fleshing out the rest of my class here. We need to have some fields to store data. So I'm going to have a public string field that's going to store my patient name, and then I'll also have a public field, and I'm going to make this of the integer wrapper class, just as because that'll be a little bit easier to work with for doing compare to here. And this is going to store the priority of the patients. And I'm going to provide some JavaDoc for my two fields here. So patient name is the name of the patient. Priority is going to be the priority rating. And I'm going to add a note here that higher values have higher priority. This is something that we're going to have to keep in mind when we go and implement our compare to method. And I'm just going to go ahead and make a simple constructor. It'll be public, and it's going to be called patient, and I'll have it take two parameters, a string with our patient name and a primitive int with the priority. And I'm just going to go and store those values in the corresponding fields. So I'll say this.patientName equals patient name, and this.priority equals priority. Java will take care of automatically converting the primitive int priority to the wrapper class integer here for this priority field. And we'll provide some JavaDoc just to make sure we have everything clearly listed. So this is a constructor for emergency room patient. We've got our name of the patient and our priority of the patient. Now let's go ahead and tackle the compare to method. I'm just going to strip out the stub code here. The first thing I'm going to do is make sure that O, the patient that we're comparing to, is not null, because that's going to cause us a problem here when we try to go and compare values. So I'm going to say if O is equal to null, then I'm going to go and throw a new null pointer exception with the message that object being compared cannot be null. Assuming that it's not null, what I'm going to do is go and use the compare to method that already exists on the integer class, because I really don't care about the name. That's not really going to matter too much to me here when I'm trying to figure out what patient I'm going to see next in the ER. The priority number is what I'm going to base that decision on. So here I'm going to go and compare the priority values, and I want to go and use the compare to method on integer, but there's going to be an important difference. Integer is going to go and sort things so that lowest values come first, but I said that in my definition here with the JavaDoc that higher value should have higher priority. So I'm going to have to invert the answers that I get from the compare to method of the integer class so that the higher priority values are treated as being higher priority. So here I'm going to return what I get from calling compare to on this dot priority. So I'll do this dot priority dot compare to, and I'm going to compare it to O dot priority. And then to invert things, I just want to go and multiply by -1. That'll go and convert a negative value to a positive one and vice versa. So that'll go and get stuff sorted in the order that I want. One final thing I'm going to do with my patient class is I'm going to override the toString method. So I'm going to have a public method here that'll return a string called toString. This way, if I go and print a patient object, I'll be able to see what data I have stored inside of it. For this method, I'm going to return the result from calling string.format, and this will go and format a string just like if I went and called system.out.printf, except for here it's going to return that string rather than print it to the console. The first argument for string.format is going to be my formatting string, where I specify how I want to have things be set up. So I'm going to do %s for a string, and I'll put the patient name there, and then I'll do a dash and a %d with their priority. I'm going to need to provide two arguments here. The first one's going to be my patient name, so that'll be this dot patient name, and the second one is going to be the priority. So that'll be this dot priority. Now let's go and use our patient class along with our linked priority queue to go and actually demonstrate how this is going to work. For my comparable objects project, I'm going to go and adjust its build path by going into the properties for the project, and on the class path under Java build path projects, I'm going to go ahead and add my linked priority queue, and I'll also add the nodes and my priority queue interface. So I'm going to add actually all the projects. I'll tell it OK, and then I'm going to tell it to apply and close. I'm going to go and make a new class. So I'll right click on the source folder, go to new class, and I'm going to call this comparable demo, and I'll click finish. And provide some. I'm going to create a main method since I didn't actually check the box to have it do a stub with that. So it's going to be a public method. It'll be static and void, and it's going to be called main, and it's going to take a string array called args as its input parameter. Inside my main, what I'm going to do, first of all, is create a priority queue for patients in an emergency room. So I'm going to go and make this object be of type based off of my interface. So I'm going to have priority queue interface, and the type that I'm actually going to store inside of the priority queue will be patient, that new custom class that we just made. I'm going to call this object patients, and it's going to be a new linked priority queue for storing patient type objects. I'll use the quick fixes in Eclipse to go and import my priority queue interface and the linked priority queue class. Patient is already in the same default package that this class is, so I don't have to import that. Once I've got my patients priority queue, I can go ahead and add some patients to it. So I'll do here patients.add, and then what I'm going to add will be a new patient object. So I'm going to call the new patient constructor, and I need to go and give the name first, and then I need to go and give the priority for that patient. So we'll just go and add a couple people here. So I've got Brian, Robert, Sarah, Tom, and finally we'll do Michelle. So we know that the higher values for the priority are the actual higher priority. So essentially, if we're trying to triage our patients, Robert should be the one that's going to be seen first, with Michelle last. What we're going to do is we're going to go and print out our patients in order. And I'm going to make use of the fact that we have toString implemented on our patient class and also on our linked priority queue class. So what I can do is just call system.out.println, and I can just pass it patients. And that should go and give me a nicely formatted list of, in order, the patients that I need to see and what their priorities are. Let's go ahead and run this. And you can see that Robert comes first with the priority of 70, and then Sarah, then Tom, Brian, and Michelle. Everything's sorted in order here. So basically what happened is that we called the toString method on our patients object, which is of our linked priority queue class, and then the toString method in there went and called the toString method on each of the individual patient objects. So that's how this string got generated. But you can see here things got nicely sorted in order based on what we implemented with the compare_to method on our patient class. So if instead of multiplying the result by -1, I just took compare_to coming back from the integer class as it is, that would go and flip things around so that lower priority values would come first. But since that's not what we said we wanted to do, I'm going to restore that times multiple by -1 part so that our higher numbers come first. And I'm just going to finish up some JavaDoc. So I think we're good to go with our example of creating comparable objects here, as well as working with a priority queue. For this lecture's participation project, I want you to download the starter code that is posted in eCampus specifically for the participation project. You'll need to create a new class that'll have a main method, and in there I want you to make use of the linked priority queue class. You need to store at least 5 values in the priority queue. It's up to you what type they are and what those values are. Once you have things stored, I want you to go and remove and print the values one at a time. When you turn this in, just go and turn in your class that has the main method. That's where we're going to end things for our look at priority queues. If you have any questions, join the Q&A session or send me an email. Thanks, and have a great day.